Hello, welcome to Leetcode Weekly Contest 422. We are solving problem B, find minimum time to reach last room, part 1. So in this problem, we are given there is a dungeon with n cross m rooms arranged as a grid, and we are given a 2D array move time of size n cross m, and where move time ij represents the minimum time in seconds when you can start moving to that room, basically that cell. You start from the room 0, 0 at time t equals to 0 and can move to adjacent room. Moving between adjacent rooms can take takes exactly 1 second. Return the minimum time to reach the rightmost bottom cell, that is n minus 1, m minus 1. Two rooms are adjacent if they share a common wall, either horizontally or vertically. So the idea here is that we are given a grid n cross m, and what we can do is we are starting from this uh, left topmost cell and we have to reach bottom rightmost cell. And what we can do is we can move to adjacent cells, that is right, down, left, up. So that is the basic directions in which we can move, and it takes 1 second to move from one cell to adjacent cell. So that is another point we have to keep in mind. Also, we can move to a particular cell when a certain amount of time has been passed. So let's say here it is 4 here, so we can move to this cell only when 4 seconds have passed. So you can consider it that there is a gate that will open, basically the entry to the cell will open at 4 seconds, and it will take 1 second from the cell where we are. Let's suppose here we are, and it will take 1 second after the 4 second that its gate has been opened, then after 1 second we will be at this position. So this is the overall idea. So let's see some examples and then we'll proceed. So we have this move time. Initially it is 0, then I have 4. At 4 seconds all other rest cells will open. So it says that the minimum time required is 6. How 6? So at t all the gates will open, so no matter what, because timing is 4, so all the gate will move open. So when gate is move open, I can move from 0, 0 to 1, 0. That is, it is going one step down, it is over here, and in another second it is moving to 1, 1. Let's understand this in more clarity. So initially at 0th second we are at 0, 0. Okay, so 1 second has passed. No more gate have been opened. All the gates are closed because they will happen at 4. So after 2 seconds, 3 seconds, nothing will happen. It will stay at 0, 0 only. When 4 seconds have passed, what will happen is these gates will open. Now I can move to the dungeon, can move to the adjacent cells because the gates are now open. Now in 5th second, either it can go right or it can go down. I have a choice over here. Let's suppose that I go to right. So now I am at 0, 1 at 5 seconds. Okay. Now again I will look that if gates are open or not. So since their time was 4, so now all the gates adjacent to this are also open. I can also go back, but that won't make sense because I basically have to reach bottom now. Okay, so now I'll go towards downwards and I will take another 1 second. So in total 6 seconds I am at this 1, 1. So this is how 6 came into picture. Now we have another example that's all the cells are 0. So let's see this. So this is the basically representation that I'm here, and at time 0 all the gates will be open. So now all the gates are open, I don't have to do anything, or I don't have to wait it basically. So it will take 1 second to go here or to go here. I can go right and left, and as per this question you go anywhere and keep moving either to right or bottom, and eventually will land up to n cross m, n minus 1, sorry, n minus 1 and m minus 1 in the same time. How so? Because in 1 second you will reach here, another second you will reach there, and in third second you will be here. If you go here, then you come to here, and if you go there again 3 seconds. So otherwise you come down and keep moving right, in 3 seconds you will be there. So this is the overall idea. The third example is that at 0, 0 you are here. At 1 second this gates will get open. I can go here and here no matter, since the values are same, so it won't affect. Let's suppose I move it to here. So at 1 second it got open, in second second I will be at this cell. Now in second cell the time has also been 2, so this gate will also open and I can come to here, and it will take exactly 1 second. So in another second I will bet 1, 1. So the time here is 3. So this is what we have to do. The very simple thing when it comes to grid traversal and with some certainty is that we can make use of the graphs. We can make use of the traversal technique, that is DFS or BFS. Okay. What I am planning here is that I will be using BFS because I have to minimize the distance. I can, or distance, or let's assume in this question we have to deal with time. So I have to minimize time moving to a particular cell. So that is my overall idea. So there are two things to keep in mind. That is, whatever the current time I am here, let's say I have some X time. So this will be my current time. And if I want to move to this cell, there are two options for me. Two options will be the current time plus one moving to there. Otherwise, the time here, whatever we have, the time it requires for this gate to open, the adjacent gate to open, that time plus one. Because in order to move it to here, plus one is basically a traversal second, that 1 second it takes. Otherwise, we have to current the current time and the time of move time that we are given. So this is a very important comparison that we have, that temporary time at particular time will be the maximum of move time x comma y, the new coordinates that we want to go, plus one, or the current time plus one, where we are the current time plus one. Plus one is basically the traversal part that I have taken into account. So yeah, so this is the main crux and main idea that we have to keep in mind. So let's quickly jump over to our code and just see what I'm trying to do here. First, I have taken NNM, the basically the dimensions of move time, and that will be basically the traversal part that I have to maintain. Next thing what I did is I am maintaining a dis. This is basically to keep track of my time. So usually we in distance in grids we take the time or the distance in account. So here I have time. So it's just a naming convention that I've used, that not convention, basically it's normally view, so that is why. So this is basically the time that I will be taking account to minimize at each particular cell. Another thing is I have taken priority queue in account, and that priority queue will have a tuple of what we'll be doing, the minimum time to reach the coordinate x comma y. So that is the basically the tuple. It will take three values. I've taken PQ as my priority queue with minimum at the top. So initially I will add 0, 0, 0 because at initial point the cost is 0 in every cases, and I'm a 0, 0. So yeah, that is the crux. So sorry. Now I have the direction, so I can move in all the directions. Since I have the positive values, so I won't be stuck in an infinite loop going up, down, and just because I will be comparing at every point. That only add to the priority queue if the timing is less, and that will basically update it. So I won't get stuck in infinite loop that in every uh, sort of circular movement the time is being reduced and I'm overall going again and again. So yeah, that should be that doubt should be removed. So these are the possible directions in which I can move. I'll iterate over my priority queue until it is empty. I will take current time x and y by taking the top elements, just as we solved the BFS problem. I will pop the top element. I will check that if my x and y reaches the bottom right, then simply return my answer. Why should I be going anywhere when I'm reached? So that is the condition I have added here. Otherwise, I will try to move in all possible directions that I have. That is, sorry, right, left, based on the directions that I have taken. So this basically reduces the implementation to quite a little bit. So now I have my new x and y coordinates. That is where I plan to go. So what I'll see is I basically have a check that the new coordinate should be greater than equal to 0, I and j should be greater than 0, and the new x coordinate should be less than n, new y coordinate should be less than m. And this is the comparison that I explained, that I will be taking the minimum of the new move time, because either I have to wait until I go to that particular cell, or the current time plus 1 is greater, then simply I'll make a move there, so plus 1. So I will have the temporary time, and I will compare that in the distance part for I and j, new x I and j. If it is let, then update my distance of new x and new y to particular time, and then append that to my priority queue with updated temporary time and x and y, so that all the rest adjacents can update accordingly. And if I'm not able to do, simply I've written minus one, but as per the question it will be possible. So yeah, this was all for this question. If you have any query, do comment it out, and do subscribe for more daily content. And yeah, that was all for this question. Thank you.